Alright, so we're going to focus on rationalizing the denominator. So I have three problems, all varying from pretty easy to a little bit more challenging. Alright, so first we cannot have a house in the denominator. That is not allowed. So what we're going to do to be able to get rid of that is actually multiply by a fancy 1 of whatever the radical is. And so square root of 4 over 4 is actually just equal to a fancy 1. So outsides with outsides, inside with insides. 3 is on the outside, 4 is on the inside. Then again, outsides with outsides, and 4 is on the inside. Now, what you can do with that is we are going to kick a twin out. So we have 3 square root of 4 all over 4. But then, actually, if you should have noticed, square root of 4 is just equal to 2. So it's going to become 3 times 2 over 4, which is 6 over 4, and then you've got to reduce that. You divide each by 2. 6 divided by 2 is 3. 4 divided by 2 is 2. Now, if you could have looked at the beginning, we didn't really have to do that because this square root of 4 right here, again, this just equals a 2, so it would have been 3 over 2. But either way works, and this is the basic way to be able to do it. Alright, so next one's a little bit more complicated. Again, I can't have this radical in the denominator, so I'm going to multiply by the fancy 1, which is going to be square root over 5 over square root of 5. So then again, outsides with outsides, insides with insides. I'm going to have 3 on my outside. I'm going to have 2 times 5 on my inside. Then I'm going to have 5 and 5 on my inside on the bottom. So then a twin gets kicked out. So I'm going to have 3 square root of 10 all over 5. You can sometimes reduce the outsides, but 3 and 5 cannot be reduced. So this is your final answer. Alright, lastly, so first what we can do, if we have a square root over a square root, let's just see if these two can simplify. Insides can simplify with insides, and then outsides can simplify with outsides. So 5 and 10 can reduce to 1, so I'll just put a 1 there for now. You don't really need it. 1 and 2, you each divide by 5, and then same thing with 20 and 10. They reduce by 10, so you're going to have a square root of 2, and then the 10 is going to be a square root of 1 if you divide each by 10. Now again, I don't need the 1 actually there, so I'm just going to have a 1. Actually, I don't even need it there. So, oh well, did not want that. So erase, please. Okay, so the 1 doesn't need to be there. I don't need to have it. But what I can have is just the square root of 2, and that's going to be over, well, the square root of 1 is just equal to 1. So it's going to be 2 times 1, and 2 times 1 is going to be 2. And this is your final answer.